Hi, in today's video, we're going to do an exercise in solubility. But before we get into solubility, let us briefly go through what is a polyatomic ion. A group of atoms that has an electrical charge is called as a polyatomic ion. The charge is shared among the atoms that form a polyatomic ion. Most polyatomic ions consist of nonmetals such as phosphorus, sulfur, carbon, and nitrogen, and are bonded to oxygen. So phosphorus to oxygen will typically be phosphates, sulfur to oxygen is sulfur dioxide, likewise carbon dioxide or carbonates and nitrates are primarily polyatomic ions. All nonmetals just mentioned, if bonded with oxygen, will always have a negative charge. For example, carbonates has a -2 charge, or nitrates have a -1 charge, and phosphates have a -3 charge, except for ammonium. Ammonium has a positive charge. Another feature of polyatomic ions is that it can never exist on its own. For example, a carbonate cannot exist on its own. It has to be attached to another atom with a positive charge. So if you have calcium carbonate, calcium is a +2 charge, carbonate is a -2 charge. The charges cancel each other and hence you get CaCO3, calcium carbonate. Magnesium nitrate has a +2 charge. Magnesium has a +2 charge. Nitrate has a -1 charge, and you combine them as MgNO3 twice. Sodium chloride, Na has a +1 charge, chlorine has a -1 charge, and hence you get NaCl only. Calcium phosphate. Calcium has a +2 charge, phosphate has a -3 charge, and so Ca3PO4 twice. This is a brief prelude to a polyatomic ion. A solution is a mixture of a solute dispersed evenly in another substance solvent. Because solute and solvent do not react with each other, they can be mixed with varying proportions. Water is the most common solvent and is often referred to as a universal solvent. Water is considered to be a polar substance. Hexane, heptane, oil, etc. are non-polar. The important aspects of solubility are the effects of temperature and intermolecular forces between two molecules. For example, sodium chloride mixed with water. Sodium ions are attracted to oxygen and the chloride ions are more attracted to hydrogen. It will go into solution. Finally, that like dissolves in like substances. Means methanol, ethanol are solvents that dissolve in water. As seen, they all end up with OH, CH3OH, C2H5OH, or acetic acid, which is CH3COOH. Usually a small structure with an OH will be polar and will dissolve in water. However, this depends upon the length of carbon bonds as well as the structure is a straight chain or a cyclic structure, and the effect of other substituents as well. Consider heptane or cycloheptane. These are non-polar, and so non-polar solutes will dissolve in non-polar solvents. Edible oils typically have long chain carbons and a lot of carbon bonded to another carbon is typically considered a non-polar compound. The bottom line is that like dissolves like. There are certain rules in solubility. Typically, group 1 elements are soluble in water, and are other compounds containing nitrates, chlorine, bromine, iodine, and sulfates are generally soluble in water. Silver salts are generally insoluble. However, silver nitrate is soluble in water. The other negative containing ions are carbonates, sulfides, phosphates, and hydroxides are considered insoluble typically. However, the carbonates and sulfides are soluble in group 1 elements. Chlorine, bromine, and iodine, which are considered soluble, are insoluble in. They are generally considered soluble, are insoluble in silver, lead, and mercury. Sulfates are soluble but are insoluble in group 2 elements like barium, lead, calcium, and strontium. These are the rules which one can use to predict the solubility of compounds. Predictions that have to be done are, in one case, the solvent is water, the solute is sodium chloride, sodium hydrogen phosphate, calcium carbonate, silver nitrate, and sodium carbonate. Try to predict whether the solute is going to be soluble. Please pause the video over here if necessary. In the second set, the solvent is heptane, the solute is water, methanol, ethanol, solute is water, methanol, hexane, and oil. However, in the last test tube, the solvent is water and the solute is methanol. Try to predict the solubility in each test tube. Sodium chloride is added to test tube 1. Add distilled water to the same. Sodium chloride bonds are broken up by water molecules, and they are attracted to the respective oxygen and hydrogen. It can be seen as soluble. Adding of sodium hydrogen phosphate, refer back to the solubility chart. Group 1 elements are soluble in water. So sodium hydrogen phosphate is seen as soluble. Calcium carbonate, basically limestone, in water addition, a white insoluble compound of calcium carbonate is observed. Refer to the insolubility chart. Carbonates are not soluble in group 2 elements. Even after shaking, it will disperse and look like a white colored suspension. Calcium carbonate is considered insoluble in water. The fourth test tube is sodium carbonate and water. Sodium carbonate in water is clear and hence considered soluble in water. Silver nitrate add water. Silver ions are insoluble, however, with nitrates it is clearly soluble. All nitrates are extremely soluble. This exercise is now complete. The next exercise is where both solute and solvent are liquids. Remember, like dissolves like. Heptane is considered as a non-polar substance, use a dropper full of heptane for the first 4 test tubes. Add water to the first test tube. Two layers clearly separate. Which liquid floats at the top? Question. Add methanol to test tube 2, which contains heptane. Predict the solubility. Two distinctive layers are seen. Predict which layer is at the top. Add hexane to the third test tube containing heptane. It is one single layer, so hexane is soluble in heptane. Using Crisco to the fourth test tube containing heptane. The fat has gone into solution and hence considered soluble in heptane. Lastly, in the fifth test tube, add methanol to water. Like dissolves like. It's a single layer and so is soluble. Just to recap, solutes. Pause the video if necessary. This concludes the exercise in solubility. Relationship of insolubility and precipitation. A solution of sodium chloride and a solution of silver nitrate. if sodium chloride solution was added to silver nitrate solution, would it be soluble or not? While both sodium chloride and silver nitrate were clear solutions, however, on mixing with each other, silver chloride precipitates out as chlorine is not soluble with silver. Saturation. Adding sodium chloride to water, it is seen to be soluble. What happens if an excess sodium chloride is added to water? When the water is no longer able to break up the sodium chloride bonds because of the rate of crystallization and recrystallizations are the same and going back and forth, this is called as a saturated solution. However, if more water was added to the test tube, it may help in dissolution of the saturated solution. Hope you liked this video and that it brought some perspective to solubility. Thank you.